Welcome to this presentation of the Rotary Club of North Bethesda, Maryland, USA. Our club was established in 1974. We meet every Friday morning at 7:45 a.m., and we often invite guest speakers to give presentations on all kinds of interesting subjects. Please contact us through our website at nbrotary.org. And thanks for watching. Today, our speaker is Bruce Davis. He has degrees in physics and law, and he will be talking to us about climate change and what we can do about it.
Good morning. We have us again this day, Bruce Davis. I've known Bruce for many years. He's a good photographer, good friend, and I spoke to him over many years about retiring. He kept on working and working and working. He loved working, but he finally did retire. He was an attorney. I've known him for years as an attorney, and when I got his background, I was surprised to find that Bruce graduated from William and Mary, a very esteemed college, with a degree in physics. And then he was a teacher before he became a lawyer. He went to University of Virginia to get his degree in law, and he was in the law practice in the district for over 40 years. And after he retired, one of the things he picked up besides photography was interest in what was happening to our world. And so he went to the Climate Reality Project, which is basically a training program. And Bruce, why don't you say a little about that, and got him involved as being a climate evangelist in effect, passing along information that all of us need to know, and how we can contribute to the work that we need to do to control what's happening with our world. Now, this is very appropriate and good timing, because Rotary has picked this up as one of their major areas of focus. So Bruce did present to us over a year ago. But there's a lot of updated information. This area is changing very rapidly. And so, Bruce, you're on. Thank you very much for coming.
Okay, well, thank you for inviting me back. It's good to be here. And I'm pleased that Rotary has now adopted the environment as one of its now 7 foci. Let's see, I do have some illustrations for the talk, so I'd like to share my screen if somebody could arrange for that.
You should be able to.
I should be able to do that?
Yes.
Okay, well, let me try that out. This has always been, so today it shouldn't be too much of an adventure. Can everybody see the title slide? I hope. Okay, great. Okay. Well, and I'll talk a little bit toward the end of the program about what the climate reality training is like, because it turns out that there is going to be another one this year, and I want to attend, so I'll make that information available. And then the slides today contain links to various websites that you might want to look at. So I'll make sure that when we're all done today, I'll send a PDF copy of the slides to Kent, and he can distribute those to the club members. So anybody who wants to check out any of the links that I send will be able to do that. Well, last February, Bob Brenneman and I spoke to this group about climate change, and Bob, I'm sad to say, has passed away, but I'm still giving presentations on climate, and my goal is to raise public awareness and to inspire people to take the actions that they can take to help solve the climate problem. This is the Earth, our common home. It's as photographed by one of our astronauts. And the thin blue line you see at the space station is the atmosphere. And you can see it looks pretty thin in this photograph, and the atmosphere really is a very limited resource. If you go up 10 miles, you're beyond 85% of it. And we'll see in this program that human activity is changing the atmosphere's chemical composition. This causes the planet to heat up, and we'll see how that happens. One way we change this, we burn fossil fuels for energy. Fossil fuels are the decomposed remains of plants that lived millions of years ago, about 300 million years ago. I was staggered to find that fact. Fossil fuels contain carbon from the plants, and when fossil fuels are burned, the plant carbon combines with oxygen to form carbon dioxide, which is a greenhouse gas. And most of you have heard about the greenhouse effect, but I'll just go over it briefly. Solar radiation in the form of light waves comes from the sun to the earth. It passes through the atmosphere. Most of this radiation is absorbed by the earth, and any object that absorbs energy under the laws of thermodynamics radiates that energy in various ways. These red arrows are the energy from the earth that's radiated, and it's a different kind of energy. It's not light waves, it's heat energy. So the infrared spectrum of energy waves. So some energy is radiated back into space, but some of the outgoing radiation is trapped by the Earth's atmosphere and warms it. And greenhouse gases are the gases that are in the atmosphere. Now, the greenhouse effect is not all bad. If we didn't have the greenhouse effect, the Earth's surface would be at a temperature of about 30 degrees below zero, and life on Earth would be very different than it is now. But the way I think of greenhouse gases is that they're like a blanket. If you use a blanket when you sleep at night, it gets your body's heat and it keeps you comfortable. One blanket is okay. If you put on too many blankets, you get too hot. And that's what's happening with the Earth now. We're trapping too much heat, and the Earth is getting too hot to maintain our current environment. This chart is from the Environmental Protection Agency, shows the greenhouse gases that we are dealing with. And the most prevalent greenhouse gas is carbon dioxide, which causes 81% of the heat trapping effect of the greenhouse gases. We also have methane. Methane accounts for 10% of greenhouse gases. Methane is a much more powerful gas in terms of heat trapping effect than carbon dioxide is. But fortunately, there's nearly as much methane as there is carbon dioxide. Other greenhouse gases are so methane's 10%, nitrous oxide is 7%, and we have fluorinated gases, or HFCs, as 3%. So where do these come from? Well, carbon dioxide mostly comes from combustion. We burn it for fuel. We burn coal for fuel. We burn oil for fuel, or we burn natural gas for fuel. Methane is basically the same thing as natural gas. That gets released primarily from farming, from raising animals that have digestive systems that release methane gas, and from exploration for natural gas, and basically leaks. So when there's fracking is done, a lot of natural gas leaks out of the soil or out of the gas pipes and goes into the air. Dioxide is generated primarily from agricultural purposes. Fertilizer and improper fertilizer use contributes a lot of the nitrous oxide. This is an extremely potent greenhouse gas in terms of its effect, but fortunately there isn't nearly as much of that as there is carbon dioxide. And finally, there are fluorinated gases, which we'll call HFCs. They account for 3% of the global warming effect, but they are much more powerful than any of the other greenhouse gases. They're about 4,000 times as powerful as carbon dioxide. And you may have read the Washington Post article, which talked about the problem of fluorinated gases leaking out of refrigerants, particularly in grocery stores, and causing a big problem in terms of global warming. Fortunately, these are on their way out. The relief legislation at the end of 2020 provided for a phase out of fluorinated gases, and there are other substitutes to replace them in refrigeration. This is a man-made problem. People developed fluorinated gases because the previous refrigerants were depleting the ozone. So now we're not depleting the ozone anymore, but our refrigerants are warming the world, and we expect that the next level of refrigerants is going to get it right, and we hope that's the case. So this graphic from the EPA shows global warming emissions by economic sector. So we see that transportation and electric generation are number 1 and number 2. We think that it's going to be a lot easier to get electricity emissions reduced than it is for transportation. We can talk about that later. Industrial uses are 22%. Agriculture accounts for 10% of global emissions, primarily from methane. Then we have commercial building use, 7%, residential use, 6%. Our problem is that carbon dioxide levels are now, I'll call it, flying off the charts. According to NOAA, the National Oceanic and Atmospheric Administration, for about 800,000 years, carbon dioxide levels have been in the range of 150 or a little over 150 up to 300. So 800,000 years is a long time. People in their current form didn't show up on Earth until about somewhere between 40,000 and 100,000 years ago. But the carbon dioxide levels stayed in this narrow range, but recently they have jumped beyond 300. They're over 400 parts per million in terms of CO2 concentration, and the level is increasing. And the explanation for this is because people started burning fossil fuel for energy. You've heard the Industrial Revolution started about 750 and really, or 1750 and really took off in the 1800s. And so people started burning coal, and then oil was discovered in Pennsylvania, and people started burning oil, and people have been burning natural gas. So all these fossil fuels burning them has caused carbon dioxide emissions and has raised the concentration to its current level. This is the last 60 years of data. NOAA measures carbon dioxide levels at the top of Mauna Loa Observatory in Hawaii, where there are not not any local emissions sources. So it's about the best place in the world to measure what's the average carbon dioxide level and how's that changing. And you can see from so it's in 1960, we were a little below 300 parts per million. And now we are 100 parts per million and climbing. And you can see from the slope of this graph, the line is curving upward. And what does that mean? Well, the upward curve means that the concentration of carbon dioxide is accelerating. You might wonder why the line is jagged. The red line is the line that plots actual measurements. The black line is the line that is an average. And the reason that the red line is the actual measurements are jagged is because carbon dioxide levels are seasonal. In the summer where plants are growing, the plants are sucking carbon dioxide out of the air and reducing the concentration. In the winter, the plants aren't doing that. So you see the concentrations falling in summers and rising in winters. And we're basically concerned with the northern hemisphere plant growth, because most of the world's land is in the northern hemisphere, and so that accounts for that accounts for the southern hemisphere doesn't balance it out in terms of removing carbon. What's changed since last February when we talked about this before? The world has gotten hotter. Most of the warming has occurred in the past 40 years, and the 7 most recent years are the warmest. 2016 and 2020 are tied for the warmest years on record, and the last decade has been the warmest decade on record. We're continuing to see heavy rainfall. This is Route 50 on Maryland going west from the district. Going east from the district in September of 2020. Hurricanes formed in record numbers during 2020. And so here you can see Hurricane Sally approaching the Gulf Coast, which caused a tremendous amount of damage. Western wildfires, an unprecedented climate change fueled event, experts say. So this was in September 2020. And you can see from this NASA photograph, San Francisco is being enveloped by the smoke from wildfires. So is the state capital, Sacramento. This is a photograph of San Francisco's skyline at 10:25 a.m. And you notice the sky, it's all orange. And it's that way because the smoke is, the sunlight's being filtered by the smoke. And so you don't see a clear sky, you see this ugly orange sky. And this caused a public health emergency. On August 26th, the Health and Human Services Secretary declared a public health emergency in California due to the wildfire smoke. We had a very bad year for drought, according to this chart prepared by the USDA and other agricultural organizations. The red marks areas of extreme drought, which we see particularly in Colorado, Oregon, part of California, western states. Severe drought in most of the western states. And this is due to heat. Well, we've seen the challenge. It's gotten a bit worse the last year. And now let's look for solutions. What do we as a group and what do people as individuals need to do to stop global warming? Primarily, we have to stop using fossil fuels. And how do we do this? Well, we try to electrify almost everything that can be electrified in terms of energy use. We have to produce carbon-free electricity, which would be generated by low power, wind power, a bit by nuclear power, and a bit by hydropower. And we have to make everything energy efficient, so we are not using so much energy that we have to be burning fuels that emit carbon dioxide. We have to reduce non-combustion greenhouse gases. That would be methane, nitrates, and HFCs. And we have to preserve and nurture ecosystems that sequester carbon dioxide. As we know from biology, the plants, basically plants breathe in carbon dioxide, they breathe out oxygen, and that helps keep the carbon dioxide levels down. Now, there's no one solution, but this book that came out in 2017 proposed that if we use multiple solutions, we can actually stop putting more carbon into the air and start taking carbon out. And that's the idea behind Drawdown, the idea that we could take carbon out of the air and maybe go back to some earlier times in terms of carbon dioxide concentrations. So it's a comprehensive research-based plan for reversing global warming. The authors say there is no one solution to climate change, but multiple solutions could do the, and Drawdown, the book sets forth 80 solutions based on physical science and economics. They had a great research team working on this book. There have been further subsequent studies, and so a lot of people are working on this, but Drawdown is based on pretty solid science. I haven't seen anything refuting their proposals. So let's look at Drawdown's top 10 solutions. We have wind turbines, basically windmills that generate electricity. Utility scale photovoltaics, so basically solar panels that take the sun's energy and turn it directly into electricity. Reducing food waste. About 1/3 of all food produced is wasted, and this waste accounts for 80% of the global carbon dioxide emissions. A lot of the food, basically, if we could use the food efficiently, we would be emitting 8% less carbon dioxide. Plant-rich diet. As I mentioned, raising meat usually results in carbon emissions, and we'll talk about why that is later on. Health and education, particularly educating, is an important way to reduce carbon. And why is this? Well, it's because educated people tend to have fewer children and so there's less people in the world to emit carbon. And educated people are better stewards of the land. So I know one of Rotary's foci is to provide a better basic education for all. And this is certainly going to help the carbon dioxide problem. Tropical forest reforestation, trees suck carbon out of the air, that's great. Improve clean cook stoves. This one surprised me a little, but it turns out that in many developing countries, the people cook using charcoal and other carbon emitting fuels. And so if we could just help people throughout the world get better access to cleaner energy for cooking, that would be a big step. Distributed solar photovoltaics. What this refers to is putting the photocells that generate electricity close to the people who use that electricity. So an example would be solar panels on building roofs that supply energy for the building. And by having the source of the electricity close to the user of the electricity, it not only generates more electricity, but it reduces the losses that occur when electricity gets transmitted over long distances. Refrigerant management, so we got to keep our refrigerators from leaking refrigerant fluid. And finally, alternative refrigerants, replacing the HFCs with refrigerants that don't trap carbon, or don't trap. Let's talk about reducing personal emissions. I've got a long list of things that can do to reduce their personal carbon emissions. And I don't have time to talk about all of them today, but I will focus on 4 areas that I think would do the most good. First is transportation. I think everybody ought to be giving serious consideration to making their next car electric. They don't, and over their lifespan, they don't cost more than regular gasoline cars because electric fuel costs less than gas. They cost more. They cost more when you buy them initially, so they're pricier to buy, but over their lifespan, they cost about equal, or in some cases less, than gasoline cars do. Did you know that an electric car motor contains about 1 moving part compared to gasoline cars contain hundreds, if not thousands, of moving parts? They're much easier to maintain, and electric fuel costs about half as much as gasoline, or less. Get your electricity from wind power. We'll talk about how to do that. Heating and cooling. Home heating and cooling is a major source of carbon emissions, and we'll talk about how to do that more efficiently. And then finally, food. So avoiding food waste and eating food that contribute less to carbon dioxide release. So we'll talk about transportation. Use public transportation instead of driving, bicycle or walk when you can. Telecommute, we're doing a lot of that these days. Keep tires on your car properly inflated. When you drive, observe the speed limit. When you go above 55 miles an hour, fuel economy decreases dramatically if you have a gasoline car. Carpool, we're not going to be doing that, I guess, during the pandemic. And fly less. And finally, drive an electric car. This is my wife's and my electric car. It's a Kia Niro. It has about 240-mile range, and we fuel it at home, and the fuel costs a lot less than gasoline. If we compare vehicle emissions, the Department of Energy has a good website on this, and based on where you are, it can compute the average emissions that come from the different kind of cars. That will change by regions because it depends partly on where you're getting the electricity. If you're getting electricity from coal, there are going to be a lot more emissions attributable to getting the electricity from wind, in which case driving your car creates virtually no emissions. But anyway, these are the usual electric sources in Maryland. And according to the chart, these are the annual emissions from a gasoline car, from a hybrid, from a plug-in hybrid, and from an all-electric. And you can see the greater the electrification, the less the emissions. So if you have a hybrid car, you're only emitting about 60% of what you would emit with a gas car. If you get a plug-in hybrid, which is a hybrid car with a big battery, and you can charge it overnight in your home if you want to. So if you have a plug-in hybrid, your emissions are about 40% of what a gasoline car would emit. And if you have an all electric or a battery electric car, you're emitting only about 25% of what a standard gasoline car would emit. Let's talk about electricity. You can actually buy green electricity at home. I expect some of you have done this, but if you haven't, this is the easiest way in the world to reduce your own carbon footprint. And it doesn't cost you, basically it doesn't cost you any extra money. And we'll see how that happens. So if we don't choose another supplier, Pepco supplies our electricity. And about 60% of Pepco's electricity comes from fossil fuels, coal and natural gas, 34% from nuclear, and only 5% comes from renewable sources like wind and solar. But Maryland law allows us to choose a different electric supplier. And there are some organizations that supply wind power that we can choose from. In fact, we can buy 100% wind generated electricity for what Pepco charges. Switching to do this is easy. It takes you about 30 minutes at the most at your computer. 15 minutes is probably more likely. And so you sign up online with a green supplier. Supplier notifies Pepco. The supplier takes care of the paperwork. Pepco sends you one monthly bill based on the supplier's charge for electricity and on Pepco's delivery charge. And then that charge is the same or not. Pepco is your supplier. And Green E supply, these are the so-called Green E suppliers who have passed Green E's standards for renewable electricity. And these were the charges as of January 31st. And you can compare their prices to what Pepco charges. And as of January 31st, we see that if you sign up with AEP Energy, you can get electricity for just a little bit less than what Pepco's price to compare. And so this is worth doing. It doesn't cost you anything, and you get wind-powered electricity as opposed to electricity that's generated largely by fossil fuels.
May I ask a question?
Yes, sir.
First, let me tell you that my wife and I are ecologists. We are doing all of the sorting of our garbage. And I'm driving a hybrid plug-in car. I am an environmentalist in the same way that I think most people are. What I'm interested in, if you have this information, how much of the pollution that we're worried about is caused by human beings in comparison to the pollution that is, as it were, natural? I'm thinking about giant forest fires, eruptions of various kinds. We had that terrific Iceland eruption of a few years ago. Do you have any sort of a estimate of what portion of the pollution is human caused and how much is caused by nature itself? Is it, are the proportions roughly equal, or are they highly disproportionate?
Well, the answer to the question is that if you didn't have human beings here, you would have carbon dioxide levels between the up to 300 parts per million, as shown in that chart. So before there were humans, carbon dioxide levels fluctuated from about 150 parts per million to 300 parts per million. And now, as a result of human activity, you have them going much higher. So I would say
Could you put that in percentages so that you can say that the human part is such and such a percentage and the natural part is such and such a percentage?
well, if you go by that chart, it would be just a rough approximation would be 75-25.
Which proportion is which?
Oh, the natural is 75, humans 25.
So we are working
That's
a great deal to reduce the 25% part.
The 25% is what humans cause and what humans control. And if we didn't have humans doing that, we would have a much cooler planet.
But I get the impression when I listen to most environmentalists that we are the main culprits. The burden is really on us to make a systematic, sustained, protracted effort.
And I would agree with that, because the burden is on us. We can't control what the rest of the planet does. We only control what we do. And if we weren't doing what we're doing, temperatures wouldn't be rising. So that would be how I would respond to that question. Going another issue. Let me get some guts here, because I know we're getting toward the end of your usually scheduled time. So how many more minutes should I talk before we wrap up? So
can we give some time for Q&As?
Yeah, we need time for Q&A and
Yeah, if you could go ahead and if you wrap, we're at the bottom of the hour, so go ahead and.
Okay, I didn't hear your
Take a
answer.
few
I'm
moments.
sorry.
We're at the bottom of the hour, so go ahead and if you have you take a few to wrap up and then take some questions.
Okay. Well, the other things to consider are stopping home energy, and I'll send you the slides which pretty much explain things. Let me go through them rapidly. You can use empowerment. They will subsidize home energy efficiency improvements in your house. So we had Empower Maryland come to our house, and we installed $6,000 worth of insulation, duct sealing, and leak sealing, and Pepco paid for half of it. And you're already paying for this from your electric bill. So if you want to improve your home energy efficiency, make sure to do it with a Pepco approved contractor, and you get half to pay for. So we will skip through this. Food, plant-rich diet is the fourth most important solution to global warming, according to Drawdown. Cattle rearing generates more greenhouse gas emissions than transportation. And if Bill Gates, my favorite quote from Bill Gates, if cows were a country, they would rank third in greenhouse gas emissions. Here's a graph showing meat's carbon footprint, and you can see that beef and lamb, when you eat those, you're really contributing to the carbon dioxide output. And if you eat milk, tofu, beans, vegetables, you're contributing much less to carbon emission. Reducing food waste, we've talked about that a bit. And I want to encourage everybody to be climate activists in their own way. The environmental impact of seemingly insignificant voluntary actions is greater than most people realize. People tend to do our example influences the people around us. And so if one person starts putting solar panels on his home, that might inspire other people to do the same thing. So what Robert Frank writes about in his very interesting book is a phenomenon called behavioral contagion. If a lot of people individually start setting an example, other people follow. So I encourage everybody to do some actions in their own life to stop global emissions, and your example will affect other people. This is your book on the subject, very accessible and has good science in it, and a very interesting memoir by a biologist who is taking on her own course of action to stop global warming. So I urge people to speak out, join an organization. There's many excellent organizations that are working to prevent climate change. The Rotary Club is one of them, thanks to its new initiative on the environment. Here's a page I got from the Rotary Club website. Climate change is happening, urgent action is required. I couldn't agree more. Here are some other organizations that you might want to consider joining in addition to the Rotary Club. And finally, if anyone is interested in becoming a climate reality leader, there's going to be a training from to me too, which focuses on the United States, and it's free to take the training program. You do have a commitment after you do the training program to give at least 10 presentations a year, and it's free. You have to apply and you have to be accepted in order to go to the training, but it's intensive, it's worthwhile, and it's very educational. And if anyone is inclined to do that, I recommend it. So that's the end. Thank you for your attention, and I hope you will all become climate activists in one way or another. And if you have any questions, send me an email. I'm looking for speaking opportunities, so if anybody is a member of an organization that would like to hear this presentation or even a longer one, I am available. And now,
thank you very much.
Questions and stuff.
So Bruce, I have a question. This is Bob Sonomane. The question has to do with the commitment at the world level or at the global level, because the Montreal Protocol, which several countries have signed several years back now, yet the Western Bloc countries like United States during the last administration basically ditched and called the climate change as a hoax. And other countries which are supposedly trying to reduce the ozone depleting substances, if you want to call it, are the chemicals which has impact on the climate change, like India and China, and still increasing the coal production in those countries and some other countries too. So in terms of the world policy or the global policy, it seems there is not really a commitment, real commitment on the part of the politicians in some of these countries, including in our own country. I know Biden administration would like to go back and go to implementing some of these things. So what's your comment on this? What I'm saying, the level of commitment on the part of certain countries in the world.
My comment is we have to get a worldwide solution to this problem. It's not something that any one single country can do. I think the U.S. needs to set an example, and we've been setting a bad example for the past 4 years, and now we're back to perhaps setting a good example again, and we need to show leadership. I know China has made a commitment. They're supposed to be carbon neutral by 2060. That's the world would like them to be carbon neutral by 2050, but they have made a commitment. And we are going to face the problem that countries like China and India that are developing, the people there are going to want to increase their living standards, and they're going to they'll need to use energy to do that. And coal is the cheapest form of energy they can get. So that is a big problem.
Yeah, but their argument is, because I was involved in the Montreal Protocol, specifically dealing with India on the part of the EPA, and their huge argument saying we means the developing world, have about less than 28% of the pollution that we cause compared to the Western world. So why are enforcing us this Montreal Protocol? It took a long time for countries like India to sign the Montreal Protocol. As the point I'm getting at, there's no real commitment on the part of certain countries, including ours here. So I think it's a long-term problem in terms of making policy changes, the lifestyle changes that are required in order to reduce the pollution.
If I could just interrupt for a second, I know we are beyond the hour, so if people need to leave, please feel free. If you want to stay on and continue the discussion, if our speaker can, you're more than welcome.
Okay.
So I'll go back to Bob's question.
Yeah. Well, Bob, I think you raise a good point, and I can sympathize with the countries who say we can't afford it, or you the developed world have caused this problem. Why should we be part of the solution? So that's a point. And then one of the provisions of the Paris Agreement, it does call for the developed world to make financial contributions to ease some of the problems of the developing world. So I think that's only fair.
I have a question if I could ask. We're overdue for an ice age, right? I mean, the ice age that's been happening periodically over the millennia is due to occur, as far as from what I understand, and perhaps may even be overdue. And some say the greenhouse gases, the man's emissions, have sort of prevented that. Now, what I understand, ice age was made North America, certainly the United States and north of it, uninhabitable. I mean, you could not live up there, and the water level is decreased considerably, and it may have even been responsible for man's movement around the world, to populate Europe and every other parts of the world. So my question is this: I mean, why is global warming bad if, in fact, we may be preventing an ice age, which sounds to me is considerably worse than any global warming that could occur?
I don't think you can predict. I don't think you can predict when an ice age is going to happen. I don't think that's something.
From what I understand, the ice ages have lasted a certain number of years and followed by a briefer period, ice age period, meaning 10,000 years.
Well,
and it doesn't happen all of a sudden. It's a gradual process. And I mean, there are people who suggest that the ice age maybe not even prevented, but slowed down by the greenhouse gases. And I always wonder whether that's not a beneficial thing.
Well, let's say hypothetically, let's take your premise and assume, okay, if we didn't do anything, there might be another ice age. But consider the timing. When do they happen? Every 10,000 years? Every 20,000 years?
The ice ages were I think more like 80,000 years.
Okay.
The warming periods are actually much briefer, like 10,000 years.
Okay. Well, I would just put it this way. I would not want to, I would not want to jeopardize our human existence as we now know it on the speculation that that's going to prevent an ice age 10,000 years from now.
Well, no, I don't. I think from what I've read that the ice age is actually overdue and perhaps may have tried to start within the last couple thousand years, that human, not just the industry, but actually, farming and whatnot, that human civilization has sort of started, may have altered that course a bit. The ice age, as I understand it, had nothing to do with global warming or CO2 or anything like that. It had to do with changes in some parameters, perhaps the Earth tilt. I don't know. I mean, I don't.
No, the scientists have looked at the various other explanations for ice age. It doesn't deal with, it's not based on Earth tilt. It's not based on what the,
Well, I don't know if
it's not based on the variations in solar energy. There's not science that can tell you when an ice age is going to occur. So I would disagree with the premise that we are preventing, there's any degree of certainty that we're preventing another ice age, but there is a high degree of certainty that we are creating an environment that it's going to be very difficult or impossible for people to live in unless we do something.
That's my understanding. My understanding is the rate of change is just so dramatic. We're changing our atmosphere very, very, very quickly compared to what world history has been. It would take millions of years for the world to change temperature by 1 degree. We're doing it in 50 years, 40 years.
I might argue that we don't have data that could be precise within a period of a few hundred years. I would think you wouldn't. I don't know if we can know what the temperature changes that occur, let's say 1 million years ago, what temperature changes occurred in a 100, 200 year period. I don't think we have any of that data.
Well, I think we do have.
My point
We
is.
we do, Steve. But it's interpreted by, well, that's a whole new subject.
Right. I mean, I guess my feeling is that it does seem like the Earth is getting warmer lately. I don't think anybody disagrees with that. I guess what the premise of this question is, how much do we have? How much are we responsible for it? And if we, to the extent that we are responsible, what's the price we have to pay in terms of human civilization to try and alter what you say, and perhaps maybe, I don't know, several times. But
okay, my response to that is, it's clear that we're responsible for it, and that's the consensus of 90% of the scientists who specialize in earth science. So that's really not an issue. And then the question is, does it cost money? Yes, to prevent further global warming, it's going to cost money. And the question is, if you don't spend the money now, what economic disasters lie before us if we don't take care of the problem? It's going to be, this is the kind of problem, if you fix it now, assuming that's possible, you're going to be much better off and pay a lot less money than if you don't fix the problem.
Bruce, I had a question. I saw a documentary, a Nova show, Nova on public television last year, about geoengineering that had some of these, I considered very strange proposals to fix carbon dioxide, including giant vacuums and putting things in the atmosphere to reduce solar radiation and stuff. Does that worry you at all about some of these large projects that might mess up the atmosphere?
Well, let's take both of them. One, what you call taking carbon out of the atmosphere by chemical means, called direct carbon capture. That takes a lot of energy, and it's not at all clear that will ever be possible on the scale that's necessary to solve the problem. So I don't think that's on the horizon. And then the other issue, people have proposed putting reflective substances in the stratosphere. So I'm trying to remember the chemical. I can't remember they're talking about calcium carbonate. They've also talked about carbon dioxide. in 1991, there was a eruption of Mount Pinatubo in the Philippines. It put a lot of sulfur dioxide in the air and in the stratosphere. And what that did was reflect some of the sun's radiation coming into the earth, and the earth actually cooled for a short time. But so sulfur dioxide is not an ideal candidate because it causes acid rain. So
Yeah.
and then you have the
consequences.
beg pardon.
That may be unforeseen consequences.
Unforeseen consequences. That's a good word. And there's a book now called Under a White Sky by Elizabeth Kolberg, who talked about geoengineering as one of her topics, and they were suggesting, well, putting reflective particles in the atmosphere would turn the sky white instead of blue. So you think of what happened with the unforeseen consequences. So we go back to the case of refrigerants, where we put in we developed one refrigerant chemical to get rid of the ozone problem. That worked, but the new refrigerant chemical we developed traps heat. So you solve one problem, you could create another.
Mm-hmm.
I think the problem is really that the people who don't believe in the climate change, and there are quite a few of them, that they would argue that the economic cost of changing, let's say, the refrigerants of SCFCs and HFCs has almost triple or almost 4 times than what we used to have. So why should we do it? So there is a whole questionable, highly questionable of some of these people argue, and calling it a hoax even. And this is where I think the changing the minds of some of these people is going to be very hard, irrespective of, as you said, 90% of scientists definitely have the data to show that human activities in general is causing this problem. And so I think that is the huge policy challenge to any politicians anywhere in the world.
I have a comment on that. I think it's great that we recognize the problem, and the generational change is very important. I think the study shows the newer generation of people, they recognize the problem and they're willing to, I don't think it's a pay price, they're willing to invest. So many of the schools like Harvard's Business School, they have a program, dedicated sustainability program. I think Rebecca Henderson runs the program, and it's well accepted. So big investment companies, because of our mindsets are determined by, influenced rather, by the economic census as well as propaganda. So now the very large investment firms like BlackRock's, now they are subscribing to the sustainability issue, which essentially tries to environment in balance. So there's good news to it, but if countries like the United States and major country, we remain a leader in this, I think the world will be better off, because the nature, once we give a break to the nature, it kind of balances itself. We have seen it. Even this 1 year of pandemic, the environment kind of is trying to come back in many parts of the world, including the United States. Mm-hmm. So I think raising awareness is an important issue, very, very important issue, so that our younger generation, the next generation, we pay attention to that. See, most of the people now buy electrical cars. Many young people now buy electric cars, and so on. So hopefully we will have a better place. Thanks to all the environmentalists and scientists.
That the young people are changing, and they're embracing the fact that we have caused this problem, and they're doing the things as I mentioned, that they're buying electric cars and so on. I know I have 15 grandkids, and every one of them is involved in some way
in mitigating the problems. They're putting solar panels on their houses. They're buying their electricity from wind suppliers, et cetera. So as those people move up in the population, I think we're going to solve this problem. But it's a long-term problem, unfortunately.
And awareness, more and more awareness, and thanks to Drew for bringing. I'm sorry, our speaker today is Bruce for bringing this to attention. I think we should do more of that, and schools, and I think are also inspiring leaders to do that. And most importantly, business world has to take note of it, and I'm glad that they're taking note of it. So I'm kind of a little hopeful, although we have a lot of naysayers. I mean, it's legitimate. Everybody has a choice. So I think it's taking effect.
Well, we've gone well over our time, and it's kind of impressive that half the people have stuck with us here. Bruce, thank you very much for coming. Very good presentation. A lot of great information. The charts that you present are very simple, but yet very powerful in terms of communicating your message.
Indeed.
I really appreciate the work that's gone into these presentations. They're very educational. Thank you very much.
Thank you, Bruce.
Thank you all. I've enjoyed it.
Thank you, Bruce. Thank you, Bruce.